Thank you, Professor Ramarao, and good evening to all of you. My dear senior and youngster personalities who are keenly interested in science, it gives me indeed a great pleasure to be amidst you, particularly in this hall, a hall which is vibrating with the knowledge and wisdom of 50 years of scientific talks by very illustrious and noted scientists of probably all over the world. So it is not something that is just ordinary to get an opportunity to be in this hall on this occasion. Therefore, first of all, I would like to thank the organizers, Professor Ramarao, Professor Siddappa, and the team for providing me this opportunity. Secondly, this opportunity is particularly, I envisage it as a very great opportunity because it is in the golden year this science festival is being conducted. And that also makes me feel that I must congratulate heartily and with immense joy and pride the Science Forum of the National College for having probably the unique credit of continuing this tradition for the 50 long years, and I'm sure it will continue for another 50 and more years to come, and it will celebrate 75th year, 100th year, and continue afterwards with this great tradition. Well, when Professor Ramarao asked me to give a talk this year also, I asked him back what could be the topic. He said, if it is fine if it is something connected with physics. Then I asked for a time of 24 hours. Exactly after 24 hours, Professor Ramarao called me. What is the topic, he said. Well, really speaking, I had not decided till then. Then I immediately said, okay, you can make the topic as epochal events in physics. You have made slight modification by now, adjectives, changing this and that, all epoch-making events in physics. Well, I'm sure all of you know it is not going to be an easy task for me, neither it is going to be easy for you to not to get bored in this. But I will try my best not to make you get bored, because, not because of my effort, the subject is like that, I feel, at the end of it is like that. Well, where to start? Let me start with a small introduction. The kind of activity that this science forum is conducting is more relevant today than ever before. That is my sincere opinion. You can ask the question why. It is simply because just when after my superannuation, I started some activity in the forum with the JSS organization, with a foundation for science and society. The first thing I did was I started interacting with teachers and students, particularly from the rural area. And after some time, I thought, let me compare the students of Bangalore city with those rural students and all that. So one day, I called some 60 students, selected students of some so-called good public schools and things like that. And I asked, the first question I asked is, like most of you also do, what is your interest, what you want to be after you grow up, and things like that. Then everybody said their own way. Most of the students, as you can guess, they said I want to become engineer, software engineer, and then some doctors, some advocates, and then some literature personalities and things like that. To my surprise, nobody said that I want to become scientist. Therefore I asked them, why none of you want to become scientist? You'll be surprised to know the kind of a question that was shot back by one of the students there. They are all selected very good students. They asked, sir, what do scientists do? It was very surprising. Because they are not aware what scientists are doing. What do you mean? You have studied some science subjects like physics, chemistry, biology, and also mathematics. Isn't it? Yes. But then why do you study? Another student gave very straightforward answer. That is, sir, we study science and mathematics to score more marks and become either engineer or doctor, to get admission to those professional colleges. Very honest answer. So then, is there any other answer from anybody else? Nobody. Do you know Bangalore is famous for what? I asked. They went on telling many things, but nobody said it is the science center of the country. Then I said, Bangalore is known as science capital of India. Do you know why it is so? They did not mention, a single fellow mentioned IISc or Raman Institute or any other institute. It is not their fault. After few minutes of discussion, then I asked the question again. Now, knowing what the science can do to the society, what scientists have done and all that, just in about 20 minutes time, when I repeated the question, majority of the students said, we would become scientists. That means it is not the fault of these young minds. It is the fault of the senior persons, as the teachers in particular. They are only busy in making them understand as far as the lesson is concerned, to prepare for the examination, score marks, more marks and things like that. They never gave an approach and exposure that they should pursue science, why and how and all that. So when that is the context, this science forum can really contribute immensely, which it has been doing, and therefore before starting, I must congratulate once again. And that is also the reason I remember this and to choose this topic. Okay. Well, let me start the journey. There is a saying, I don't know why it is missing here, which Einstein has mentioned, probably many times, not one. The most incomprehensible thing about the universe is it is comprehensible. You know, Einstein is very noted person for this kind of statements. The most incomprehensible thing about the universe is it is comprehensible. You know, how beautifully it is summed up. In fact, physics, as you all know, is the study of the universe. Study of matter and energy in the entire universe. With that definition, if you look back at the development or evolution of physics in particular, it started, I should say, with the models of solar system. Or even before that, in the form of imagination. If you look at the Rig Veda, as many of my senior persons must be knowing, there is nothing that is not there in Rig Veda which exists today in the modern science and technology. What kind of a wonderful thinking our ancestors has had in Rig Veda. Before that, even Babylonians have had this kind of a thinking mind. That apart, if you come down to the subsequent years, in the 5th century BC, we have had great thinkers in Vice-Chancellor school of philosophy, for example, and similarly in Greece, Ionian school of philosophy. Almost parallelly, they were thinking on similar lines about the matter, about the world, about the developments, and try to explain them in the simple form, in the form of formulas or expressions, only in imaginary form, and write down that they were not able to give proof, or there was no need, or there was some other reason. Okay, that apart, the real thinking about the universe came for the first time in the 5th century BC through Aristotle, who described the solar system using a model. He describes in the form of a geocentric universe in which Earth was considered to be at the center, fixed, and it is surrounded by moving planets. The first geocentric model, the first model of the universe. And maybe about 100 years later came the other one which we today follow, the Aristarchus model, who is also a great astronomer, who proposed the heliocentric model of the solar system with Sun as the center and all the planets including Earth moving around. Then came, these are all at that time certainly, we may not consider these as epoch-making events, but certainly if you look at that time, these were indeed epoch-making events. The next one, another 100 years later, came the work of Archimedes. We all know, we are all very familiar with Archimedes' principle and his very famous running out from the bathtub, Eureka, Eureka, and things like that. Let me not go into the details of this. Very interesting thing about Archimedes is, he was a great innovating thinking personality. He did several work also in addition to that Archimedes principle work on buoyancy. He was the person who used the levers. He introduces the levers at that time for usage in a big way, and in order to explain the importance or significance of that lever, he says, give me a place to stand and I will move the earth. That is the kind of mental setup he has had. Well, this apart, in the relatively subsequent years came very important contribution again from Indian thinkers, astronomer, mathematician, astronomer, Aryabhatta, 6th century, who proposed that the earth rotates on its own axis in elliptical orbits around the sun. For the first time, the concept of elliptical orbit came. And then came the work of Brahmagupta about 200 years later, who recognized that gravity is a force of attraction and described a force of attraction between the sun and the earth. In fact, he has written a treatise given to the world, The Opening of the Universe, which is very well known and acclaimed. Well, it is probably in this context what Albert Einstein has said on one occasion. He says, I quote, I have the greatest respect for India and Indian people. Firstly, for the traditional knowledge that they have given to the world civilization, and secondly, for the number system, without which none of the discoveries and inventions would have been possible. That is the kind of a treasure of knowledge that the Indian ancient thinkers have given to the world civilization. Okay. And probably no other country can boast of this kind of a tradition. Well, then came the work of Newton. That is, for a long time, I don't know what happens to all thinkers in the world. For a long time, nearly 1,000 years, somehow people lost interest in science, lost interest in technology. I don't know what is the reason for that, but many people have attributed many reasons for this kind of a thing. Let us not bother about it. But very unfortunately, science had a standstill, growth of science had a standstill for a long, long time. It is only in the 17th century came the Newton's laws of motion, which is real epoch-making event in a big way in the modern science and technology. We can say it began a new science and new technology, and and whether it is physics, and that leading to other areas of science, and then leading finally to technology. And all of us know what these Newton's laws of motion are indeed. Every object, meanwhile, there also Galileo's contribution, I must acknowledge here. He is the person who, before this, made it clear to the entire world community that one can, observe the things around the world, what is happening and all that, keep them in a simplified form and explain using those simplified forms for the understanding of the common man and all that. Whether it is on the earth and also on the heavenly bodies, he made very systematic investigations, summed up and made, in a way, the modern experimental science started with Galileo. We must acknowledge that is another very epoch-making event. Then came the Newton's work. As you all know, Newton's laws basically are three, which led to the classical mechanics, and that classical mechanics is utilized even today in every technology, including space technology, of course with certain modifications of general theory of relativity. Well, there is a story which we all used to hear, where we don't know whether it's true or not, whether it's imaginative story or what, but it is a very interesting story, finally leading Einstein to develop force F is equal to m1 m2 by r square with a constant g, the universal law of gravitation, which is the basic thing for all mechanics and modern technology in many forms. Well then, Newton also proposed, I think certain slides are missing, I must just bring to your, recollect and bring to your notice. Newton also worked on light. In fact, he studied laws of rectilinear propagation of light, reflection of light, refraction of light, very systematically, and gave a theory to explain these important phenomena in the form of corpuscular theory. In other words, light is made up of particles, and using that corpuscular concept, he was able to very clearly explain all these three important experimental observations: rectilinear propagation of light, law of reflection, and laws of refraction. All the things. And everybody thought everything is quite all right, nothing more is left unexplained as far as various phenomena associated with light was concerned. But very soon, Young and many other found out another phenomena, the phenomenon of interference and then phenomenon of diffraction, which the scientists could not explain, nor the corpuscular theory of light. And for to explain that, wave theory was proposed by Christian Huygens. As long as Newton was alive, he never accepted this wave theory concept. He said nothing. Light means it is corpuscles only. He was bent upon believing that. And unfortunately, although he could not explain the diffraction and the interference phenomenon, he still behaved. But interference and diffraction very well explained by this. But there was a big dilemma, whether to believe Newton or whether to believe Huygens. Because of the fact that Newton was a great personality, most of the physicists and scientists were forced to believe the corpuscular theory of light and not the wave theory of light. But anyway, things went on. I think, but I will come back to this slide later. After this, quite a long time again, until the end of 19th century, no significant development, no significant or epoch-making events have taken place, I should say, with whatever knowledge I have. Then came the discovery, three important discoveries in consecutive years. The discovery of X-rays, the discovery of natural radioactivity, and discovery of electron. You know about the discovery of X-rays. Very exciting event in the year 1895 made by Wilhelm Conrad Röntgen. Very accidental discovery. I don't have to go into the details of the story of this discovery, but what you see here is not his own hand, the hand of his wife, Tom, and then after passing through the X-ray photograph is like this. And it is very interesting, it may be interesting to know what are the reaction after seeing this one. I am excited to see I am dead. After seeing this one, I am excited to see my death, or my dead, I am dead, and things like that. That is a very crude way of putting it. That is, after death, of some time probably, the hand will become like this, only with the bones first, before the decay and all that. That is the kind of imagination. But that incidentally, you know, all of you know, is the one thing that is responsible for the very wide-ranging application of X-rays in industry, in medical, in every field. Not only that, it showed great insight into the basic aspects of physics in a big way, which can be just seen in the form of Nobel Prizes the scientists have got using X-rays, what all they have done to delve the nature, to take physics forward. As many as 15 Nobel Prizes have been bagged in this area, and it is still continuing. The latest one being X-ray crystallography. It is the one that is responsible to solve the DNA structure and things like that. What a wonderful contribution of that one. So this is one epoch-making event. The next one came. So this is the way different kinds of machines that produce X-rays. This one is the first one, X-ray tube. Then the one that is used in hospitals very routinely nowadays. In Bangalore, in almost every modern hospital has got this facility, and this is the kind of X-ray machine used in the industry. Like that. So innumerable applications. Then the discovery of natural radioactivity, wherein some elements decay on their own in a natural way by emitting three different kinds of radiations, alpha, beta, and gamma radiations. And each of these alpha particles or beta particles or gamma photons, each one of these have proved to be very, very powerful probing tool to probe the nature very, very effectively. But for these, probably modern physics would not have been developed at all. In fact, the discovery of the nucleus itself would not have been possible, but for the use of the alpha particles by Lord Rutherford. Well, then came equally important discovery, the discovery of the electron in the subsequent year, 1897. And it is these three discoveries that are adjudicated as the events that led to modern physics. Modern physics deals either one or the other of these three aspects, the phenomenon associated with these three physics, and it is continued to provide very, very great insight to different aspects of the matter and energy. You know, the properties of, let me not come to these, let me come to these aspects later. In fact, I had arranged it, somehow it has not happened. These are the things that we have to bear with these modern technologies. Well, when these alpha particles became available, Ernst Rutherford, or Lord Rutherford, who is more familiarly known as, conducted a series of experiments using alpha particles, say from polonium alpha emitter, and making them incident on thin sheets of silver, gold, and other things, other metals, which sheets, the elements whose sheets can be made very uniformly. And at that time, now we can do all the metals sheets very, very thin and very uniformly and all that. But at that time, the technology was available only for silver and gold and a few other metals. So the Rutherford used these and conducted certain experiments using a setup like this. And you can see here how the alpha particles undergo scattering. This is the alpha particle source, and this alpha particle beam hitting on this one. It is not a hole made, it is only shown like that. Alpha particles, most of them penetrate, scatter in these different directions. That is, this is all forward direction of scattering. But few alpha particles also found to undergo scattering in the backward direction. And some even very close to 180 degree scattering, almost hitting back. And I'm sure most of you know what kind of an excitement Lord Rutherford experienced on seeing this kind of a scattering. He says it is unimaginable. It is just not, it is as if, it is amazing. It is as if you take a rifle and shoot at a very thin sheet of paper, that bullet comes back and hits you. It is that kind of a thing. Alpha particles of about 4 to 5 MeV energy hitting thin sheet of gold foil, coming back in this direction is something like that. It is amazing. He could not believe. But it is, in fact, he was more confident than anybody else, and he said something is to be looked into. How it is possible and things like that. And after great thinking, thought, he proposed one of the finest model for the atom. I must tell you just 1 or 2 sentences for the benefit of my young friends, that just before this experiment, his teacher, Lord Rutherford's teacher, J.J. Thomson, who discovered electron, immediately after discovering the electron, he proposed the first model for the structure of the atom. And according to Thomson's model, the positive charge of the atom is all spread throughout the sphere. The atom is in the form of a sphere, and that sphere, throughout the sphere, the positive charge is spread, and negatively these electrons which he discovered, he thought that they are embedded here and there, so that the total electric charge is neutralized. It is zero. Okay, positive charge on the sphere, and electron, total negative charge is due to electrons embedded here and there, spread over there, here and there, embedded. And he thought the atomic structure of the atom is okay, that is fine. He was very much satisfied. For some time it was thought so. But when Rutherford conducted this experiment and observed the backscattering of alpha particles, that model could not explain. And that is why it is called anomalous scattering, which cannot be understood by the then existing model. So it is today also referred to as anomalous scattering of alpha particles. For BSc students, there is always a question. The derivation of the formula for anomalous scattering and the experimental description, this, that, and all. Okay. And according to this Rutherford model, the whole positive charge is not spread throughout the sphere uniformly, but it is concentrated at the center in a very small region of the atom. That he called the nucleus. That is how the nucleus was discovered. So nucleus is there at the center, which contains all the positive charge and also almost the whole mass. And the electrons, which contribute very, very less or insignificantly for the mass, are revolving around the nucleus, he said. Revolving around the nucleus, just like planets do in the solar system. Okay. So this is how the first model, even today, there is no, but only thing is Rutherford was not able to say, beyond saying for the nucleus, it is containing all the mass and all the positive charge. Beyond that, he did not proceed. That came subsequently when more work was done. This is definitely very epoch-making event. The discovery of the nucleus, correct interpretation of anomalous scattering of alpha particles is an epoch-making one, as important as any other particle discovery, or probably more important than all other discoveries. In fact, there is a feeling that is almost equal to what Einstein did some time ago. Okay. Not some time ago, some time later. Okay. Then I must say, at that time already the existence of protons was known in the form of positive charges and all that, but that is, the same cathode ray experiments indicated the existence of protons, positive rays. But it was not known, these are the constituents of all atoms of all elements, That was shown by Rutherford again in his subsequent experiments in the year 1920, when he bombarded alpha particles on nitrogen atoms, and observed the emission of protons and some nucleus X changing into nucleus Y. He conducted experiments on other elements also, and in all these transformations, rather in physics language transmutation, in all these transmutations, in fact this is the first experiment conducted on a special type of nuclear reaction which explains the formation, change of one nucleus to another, one atom to another, which we call artificial transmutation, and according to which any element can be converted into gold or whatever. The only thing is cost of the conversion effort will be lot more than getting the gold itself. But if one wants to, it is possible in principle. But more than that, the emission of protons is invariably they observed in all these artificial transmutation experiments, which made him conclude that protons indeed are the constituents of all nuclei of atoms and things like that. So electrons were there, protons were there in atom, and then if it is only protons and this one, things would have been different. Mass, that was the first model also came, protons and electron model was there. Let me not go into that aspect, but very soon, say another 10, 11 years, came the discovery of neutron. Again, you observe, this is not the experiment. Again, there is some change. The neutron chamber that he used, polonium and beryllium, neutron was discovered. That there is some change, interchange has taken place there. Neutron emission was, after paraffin, not the proton, neutrons come out. Okay. If it is not only proton, then PN reaction takes place and protons were converted into neutron in the previous slide. And why I am showing this slide is, discovery of neutron is really an epoch-making discovery. Without that, the structure of the nucleus would not have been completed at all. We would not have understood the structure. But he uses, you see, what a simple experimental setup. Simple and also, if I may say so, a crude setup. What do you think? Okay. Then he observes with this, and on the one hand, source, there is somewhere in the target and somewhere at the end detector. Okay. And whatever he has used, aluminum window and all these things easily available for any window. So with this now, what the nucleus is, Rutherford earlier thought this is only A small region which contains the entire positive charge of the atom and almost the whole mass. Now, after the discovery of the protons and neutrons, the model got completed. That means this nucleus contains a certain number of protons indicated by the atomic number Z and certain number of neutrons indicated by total mass number A minus the Z, A minus Z, neutron number. So there are Z number of protons and A minus Z, that is n number of neutrons. Okay, A minus Z number. Now, as you know, always the proton number and neutron number in small, lower elements, it is okay, they are in equal number. As you go to heavier elements, the nuclei of those things have more number of neutrons and protons and all that, you know that. But what is important here at this juncture is, this model is certainly an epochal event, the development of nuclear atom model. Now, there is no experimental contradiction observed so far for this model. Okay. Oh, many things are missing, I am so sorry. I must mention here at this juncture the work done by Einstein. This is one stream of work that has gone, experimental side. Simultaneously came really epoch-making event, another event, the Einstein's work, which he published in the form of 3 papers, all in the same year, in the year 1905. And that is one on Brownian motion. This Brownian motion, the discovery was made by one of the biology scientists long ago, observation that one, but explanation was not there. The theory explaining the Brownian motion makes use of the concept of atom. Until this Brownian motion explanation by Einstein was there were a number of scientists who were not believing in the existence of atom at all. There were quite a few, because nobody could see them. So, what is the guarantee that whatever the matter, structure, element are all made up of atoms and all that? There, nobody has seen. But it is the Brownian motion theory developed by Albert Einstein, which proved very convincingly even those scientists to believe completely the existence of atoms. That is the greatest achievement of the Brownian motion theory. Equally so, the quantum. The wave nature of matter and corpuscular nature of matter was there all along continuously till that day. And there was a very, that also I had kept here, but somehow it has been not recorded. I must explain you in a very crude way. Where some old guys, scientists, see whatever we were believing after seeing this duality and all that, they thought, hey, what is this that is happening? Whatever we were thinking are particles are actually the waves, and whatever waves we were thinking are particles. That was the kind of a dilemma. By not only the very senior people, even for youngsters it was a dilemma. And that dilemma was only got enhanced. So many people were thinking Huygens theory only was correct, and whatever Newton has said, the corpuscular theory is not correct, because with wave theory you can explain all the things, all the phenomena. So there was almost the people, the scientists were at the verge of avoiding and totally doing away with the corpuscular theory. But it is the discovery of the photoelectric effect experimentally and explanation theoretically by Albert Einstein, which convincingly proved that light indeed is corpuscular in nature. It is indeed a particle in nature, particle nature and all that. So Einstein's photoelectric equation that way was very well taken by the scientific community, and it is for this work Albert Einstein was awarded the Nobel Prize. Okay. And yeah, let me just recollect one or two things. The next one is next one, of course, special theory of relativity, about which I don't have to go into the details, wherein he has explained not only the space, the time also is not absolute and things like that, you know. Till then everybody thought time is absolute, although other things are not absolute. But when you try to apply this to the law of gravitation, universal law of gravitation, he had to experience difficulty. And in order to overcome the difficulty, he had struggled 11 long years. Then came, after the struggle for about 11 years, came the another epoch-making work of Einstein, that is in the form of general theory of relativity. And general theory of relativity, although not easy to understand the mathematical details, but the kind of the predictions that it has made were fantastic. Everybody can feel it and all that. And those, one of the important prediction is the gravitational redshift, which was experimentally proved to be correct, observed gravitational redshift. And with that, the theory of relativity was accepted by everybody, and that made Einstein real hero. Although nobody could understand this general theory of relativity in spite of his struggle. In fact, there are two very interesting incidences in this connection. One is Albert Einstein himself has said, the theory of relativity is known, probably is understood only by two persons. One is God and second is myself, Einstein. I am sure about the first, I am not sure about the latter. And another very interesting thing is, he was a very big celebrity after that, big celebrity. Nobody else was as celebrated in that on that scale as Einstein. So once he was invited for the inauguration of Chaplin's picture in Los Angeles. At that time, Charles Chaplin was very popular hero. So they were coming out from the theater and big crowd was waving their hands. Lord Chaplin says, "Look, Einstein, this mob is waving with all excitement at me because they understand everything I say. They are waving at you with excitement for the reason that they don't understand a single word of yours." But Einstein took it, took the revenge on a different occasion. That is a different matter. And this is the kind of a thing that has happened for this epoch-making discovery. Well, with these things, the classical mechanics developed by Newton, subsequent refinement and all that, was able to explain what? The interaction between the masses, macroscopic bodies, whether it is some small objects here on the earth or heavenly bodies and all that can be understood through the theory of law of gravitation. But how about the understanding of the interaction of these protons and neutrons inside the nucleus, which nobody has seen? Now, what is the kind of a mechanics that is to be developed? What kind of a theory? That kind of a theory also happened to answer and solve the dual nature of the matter, whether it's particle or wave which one is correct and things like that, was understood in a very simple way with a new theory which is called quantum mechanical theory. In fact, the quantum concept itself was introduced by Planck. That itself is another very epoch-making event in the 1900s. And subsequently came the work of de Broglie, then who developed the wave mechanics, and then Heisenberg, uncertainty principle. And in a span of very few years, so many things developed resulting in a new mechanics, which was able to explain the interaction between the atom and the electron. The entire chemistry can be understood on the basis of this. And similarly, the interaction between neutron and neutron, that is interaction of nucleons and things like that. That theory of quantum mechanics is indeed also able to solve, because there it was shown very clearly that sometimes the so-called particle may behave like a wave, and the so-called wave can also behave like a particle. And the important point there, concept developed there, wave function. That wave function determines or specifies some probability for every event, whether that particle will be like this or that, whether what happens when they interact with other objects, other particles and things like that. Okay. And there are different approaches also in this quantum mechanics. In fact, all of you might have heard, Feynman has developed a new approach to this quantum mechanics. Although he is very well versed in quantum mechanics himself, and developed an entirely new approach to develop greater insight into the nature of matter through these interactions of nuclear particles, he himself says on one occasion, I can safely say, I quote, I can safely say, nobody can understand quantum mechanics. See, these are the kind of things that these great physicists have often said. Einstein has said like this, Feynman saying like that, Newton saying some other thing, but they all are really great innovative thinkers. And that doesn't mean that quantum mechanics that nobody understood and all that, but it only means that it is indeed difficult to understand. So let us not try to understand that either. In the remaining few minutes of time, I will sum up another one or two very interesting things. One is, this quantum mechanics was able to explain many great, in many great details, the interaction between nucleons, that is atomic and subatomic particles in general. Whereas the classical mechanics was able to understand this. And with these two different theories, there are not only two theories, there are other two theories also in between. One is the interaction between macroscopic objects in the form of classical mechanics, or what we call is theory of gravitation, and theory of gravitation predicts the existence of its quanta in the form of graviton, which is yet to be discovered. Then there is the interaction between electron and the atom, or between nucleons and nucleons inside the atom in some form or the other, that is weak interaction theory. The second kind of natural interaction was developed. And then subsequently came the strong interaction, and these, in addition to these three, there is another interaction, electromagnetic interaction. So these four theories are able to understand all these different phenomena, but Einstein's dream was to develop, to synthesize all these theories, to develop a new theory, and give to the world a unified theory, the attempt of which is now going on, still continuing in the form of string theory, superstring theory, M theory, and things like that. That is, theoretically, developments are indeed taking place. Experimentally, using the knowledge that whatever one has obtained through quantum mechanical interpretations and the experimental findings, many useful things have emerged, which are again, many things are epoch-making. For example, the discovery of the nuclear fission. by Arnold Strassman, wherein heavy nucleus gets split into two other medium weight nuclei when it is bombarded with a neutron. And that we called, and also there enormous amount of energy is liberated along with production of again 2 or 3 neutrons in every event, which can be utilized again to produce another nuclear fission, resulting ultimately in fission chain reaction, which can be controlled or which can be allowed to take place spontaneously in a very short time, in which we have either nuclear reactor or nuclear bomb. So both are useful in one way or the other, although they are equally dangerous. In fact, there is no event in science and technology which is not dangerous. Only thing is we should know how to use them for our benefit in a very positive way. Okay, let me not again go into those details. But another very interesting thing happened meanwhile. In the year around, in the mid of 20th century, Feynman has made one important prediction. I think that they're all missing in this slide somehow or other, I don't know, I'm sorry. I only mention very briefly, time is also not permitting. He says, the rules of physics, I quote again, rules of physics do not prohibit the maneuvering the matter atom by atom. Maneuvering the matter atom by atom, that is in the atomic scale. He continues and says, we did not do it only because it has not been done so because we are too big. Because we are too big. This is the kind of way always Feynman used to say, it is a very classical lecture he delivered. In that lecture, long before this scale matter was put into operation, developed and put into use, this prediction was made. The rules of physics do permit indeed for that kind of a maneuverability. And it was, first time, it was a biology, again, life science scientist, Eric Drexler, who wrote a paper, and yes, I think in molecular science journal, molecular biology journal, and compared what these atom by atom manipulation can be done through proteins, and so many structures can be developed in the human body. He compared the modern regular use of these facilities, whether it is pipe or whether it is needle or anything else in the mechanical side, everything else he compares and all that. So that is the first point where nanoscience and nanotechnology started developing. And even today, Eric Drexler is considered as the father of nanotechnology today. And yeah, that as a result, I think that thing is there. The carbon nanotubes developed and put into regular use. They are all in the atomic scales. Very, very thin ones, but very interestingly, using the scanning tunneling electron microscope, the image of carbon nanotubes have been taken. One can see these things, and they are put into practical use, but more excitingly, the development of graphene. At 1 atom thick graphene, only 1 atom thick graphene, which has a unique property. It is the hardest material, harder than the diamond. Yet it is transparent. Not only transparent, translucent, and things like that. See here. It has got immense, for which Andrei Zim and Konstantin Novelsko were awarded Nobel Prize very recently. Another very epoch-making discovery. And the applications in almost every field of graphene will revolutionize in the coming years. Okay, whether in the form of transistor or in the form of other usages, there are innumerable applications envisaged. Well, the story is continuing. The kind of experimental things that are going on in the Large Hadron Collider, as mentioned by Professor Ramarao, and the signatures of the existence of one important particle, its boson, is going to be announced tomorrow. That will make another epoch from tomorrow onwards when it is announced to the world. It is already analyzed very carefully by hundreds of very, very brilliant minds, and it has been proved, and tomorrow also it is going to be announced. And that way, physics is continuing to make epoch-making events. And there is no end, and I am sure the Science Forum will continue to enjoy those epoch-making events, not only in physics, in almost every areas of science. And there was, the concluding slide was there. It was very interesting, very, very interesting. I am very sorry that is also missing here. And that says, see, there were two scientists, met some senior persons, and and somebody introduces them. He is so and so, he is so and so. And those two old gentlemen, they say, oh, you have one thing in common. What is that? You have discovered galaxies and new planets which nobody has seen, and he has discovered very, very minute particles, subatomic particles, which also nobody has seen. Okay, you both have this thing in common. You are doing something which nobody has seen. Okay, that kind of these are all epoch-making events. Similarly, boson is signature. Nobody can think of seeing that. And this thing, the classical mechanics on the one hand, quantum mechanics on the other, and all the advanced theories developed on the basis of these things. The general theory of relativity is nothing but some kind of correction, so to say, of the Newton's universal law of gravitation, and without which, but I only mentioned about the physics aspect in the form of redshift prediction. But there is very interesting thing. Today, satellites are to be positioned in space very, very systematically, geostationary positioning. And but for the general theory of relativity, although one makes use of the classical mechanics, the universal law of gravitation, in the design and development and launching of these things, satellites, the exact geopositioning would not have been possible without the help of the general theory of relativity. If that correction were not to be made, it has been calculated every day correction to the tune of positioning correction to the tune of 10 kilometers have to be added. 10 kilometers every day. So that is the kind of a refinement and epoch-making things that are taking place by very brilliant minds all over the world. And I look forward for that kind of a thing. In fact, I could not mention whether it is Raman's contribution in the modern days. In fact, nanotechnology seed was sown by Indian physicist J.C. Bose at Calcutta 100 years back. He developed that is an epoch-making event. Nanotechnology, he was the first scientist who fabricated his own experimental setup and conducted the experiment and shown to the entire world community plants in the area of life. That is the starting point of the biotechnology. And today, we look forward that kind of young minds, and I am sure that our Indian young minds who are capable will receive that kind of a fillip from this kind of an organization. And I wish that the Science Forum of the National College under the able leadership, active and enthusiastic persons like Prof. Siddappa, Siddappa will continue to spread this kind of a message in the years to come. Thank you very much. Before that, sir, thank you very much. I just make it sure of that. Ladies and gentlemen, you are listening to rather story narrated by Professor Siddappa, very important milestone mentioning the epoch-making events in the history of physics. Very interestingly, he was just narrating like a story. a grandmother's story to the children in front of them. It's a very, very beautiful narration indeed, and very exact. I hope that our students here, youngsters here, are very much inspired by this talk, by knowing the epoch making events in the history of physics. Now, well, friends, tomorrow we have a talk by Professor R. Vittal Rao, Professor of Mathematics, Consultant Department of Electronics Systems and Engineering, Indian of Science. He is going to speak on Ramanujan's mathematics, simple illustrations. You are welcome to all these programs. The program sheet is here available. It is also displayed outside, a very big board, and you are most welcome to all these programs. Once again, on behalf of the Bangalore Science Forum and on behalf of all of us here, I thank Prof. Siddappa very much for having pleasure giving initiatives. Yes, sir. Questions? One or two questions you can take. Sir, because right from morning, Prof. Siddappa is very busy, hectically is working. Just one or two questions.
Contribution from India from the epoch making science are in physics.
In the modern times. Is it not? Very sorry state of affairs. Yeah, very good. It is really a great concern. Not only it is a matter of great concern. But I must acknowledge here one thing. That's kind of a thing is happening not because our youngsters are not capable of doing it, but only because we are not giving them proper encouragement and nourishing them. Okay, why I will tell you one or two incidences. The kind of training that we give right from the school days, is not conducive for the students to think innovatively and work seriously. Not thinking innovatively because we all our teachers, whether it is in Bangalore city or in the rural area, they are not giving training, providing them exposure of great scientists, how they have done this, that and all and things like that, but they are only preparing for the examination. That is one thing. Secondly, the teachers. But how about the society? Society, although everybody is reaping the benefit of science and technology, they are not encouraging. They are not aware that they are having all these benefits because of the science in particular, and our youngsters must do science and all that. They are not encouraging their kids at home. Subsequently, when they grow up, they don't think that the scientific approach is totally missing in the society. Okay, there is, in fact, Professor Narasimhaya has done, I should have acknowledged this right in the beginning, I'm sorry. He has done lot to develop awareness in the general public regarding the science, to do away with the, wrong myths and things like that, Pavada and all that he fought almost throughout his life, Pavada against Pavadas, miracles and things like that. Okay. Unfortunately, our society has not reached to that level at all. They are not thinking on all petty things, particularly in science. Even in Bangalore, for that, although it is a science capital of the country, everyday newspaper, how much we see science? Who knows what is going on in scientific research in IISc or Raman Institute or in other institutions? Who bothers? Nobody. What kind of a recognition for the scientific work the society is attaching? So many things. But I tell you, young minds are really capable. I tell you one instance, just one instance. Chamarajnagar Chamarajnagar district is considered as one of the most backward district educationally. Okay. In the last couple of years after my superannuation, I have been interacting with teachers and students at high school level in rural areas in a big way. And we provided training, for example, one example, training of making telescopes, fabricating telescopes. So we gave training to about 50 teachers who prepared about 15 telescopes for about a month's struggle. Everything they made themselves. And that was taken to, say, one such telescope was taken to Chamarajanagar's high school. Looking at that telescope, one of the students was so much inspired, looking at the telescope and also seeing the craters in moon through the telescope. He was so excited. So he went alone without telling his teacher. He has gone to Mysore, spent about only 50 rupees in collecting from Gujari shops some lenses, some holders, some pipes, okay, some long and short pipes, and then some discarded old camera stand and things like that, and he fabricated a small telescope, spending only 50 rupees. Used one lens as objective, another lens as eyepiece, and he developed he has completely fabricated. And when the exhibition was arranged, when some of my colleagues, experts in different subjects went there, he comes, sir, I will show you a telescope, my telescope I have made, it costed me only 50 rupees, I will show you moon craters. He showed us literally. A student from most backward area could do that. And there are a number of instances in different regions which I am very, very excited to see. And it is because of that we are now developing to provide them proper exposure on science and mathematics. Professor Siddappa and Professor Nagendrappa and many of us are involved in developing information support system to provide them proper exposure to learn and develop more interest in science and technology, the video episodes and e-book, with the support from Government of India. The project sponsored by Office of the Principal Scientific Advisor, Government of India. And that we are going to give to all high schools in the rural area. We are planning for that. Okay. That is very good, but for that it is the entire society who has to take this plane, not X or Y, or not just our policy and things like that. That is there. Society and government is a part of the society, I think. It is not different from society. Yeah, very much. Very much. Yeah. Yeah.
When you said there might be a press release tomorrow, you meant literally tomorrow that they found Higgs boson?
Oh, it is not just, it is last couple of years they have been studying, more than 800 dust mines from all over the world.
I understand that. Are they going to do a press release of the Higgs boson particle discovery?
In what forum they do and all that, they are going to announce tomorrow. That is what...
Literally tomorrow?
That is going to be announced tomorrow. In what forum they announce, we have to await.
Hello there. Let us assume that discovers a complete unified theory. Then, according to Einstein and Stephen Hawking and other scientists, is it possible to travel back in time?
Travel?
Back in time.
Back in time. No, that theory is not contemplated, has not been developed, is not being developed for that thing only. Nobody can go backwards, as per time cannot be made to go backward. That is not the main objective of the theory. Theory is to understand everything that is happening through one forum. That's all.
Can predict the future.
Well, that also is not the objective of the theory. That is not the intention at all. Okay. That is not the intention. There won't be any thrill at all. First of all, even Einstein and even Stephen Hawking says, we may have to do away with this. It may not be possible at all to have a unified theory, one theory, and to explain everything. That itself is doubtful. If that is the latest statement of Stephen Hawking. I think I recommend.
Be able to go back in time, but we can see happens back in the
Yes, that is always possible. Even now it is possible.
Go back in time. But according to Hindu philosophy, what is the concept of sex?
That is there. But that is all in conceptual way only. There is no clear proof, convincing proof for that. Then that is there, but 100% that is happening. Nobody can assure.
Last point subject